Hello and welcome back to Game Theory Fundamentals, Episode 5. Nash equilibrium. In the last episode, we learned about dominant and dominated strategies. Today we'll learn about the Nash equilibrium, a key concept in game theory. We'll start from the definition of Nash equilibrium and have some practical exercises, where we'll learn how to detect Nash equilibrium within famous problems such as prisoner's dilemma, battle of the sexes. Nash equilibrium is named after John Nash, a Nobel Prize-winning mathematician. A Nash equilibrium is a combination of strategies where no player has an incentive to change their strategy, given the strategies of the other players. To find a Nash equilibrium, we can use the best response method, which involves finding the maximal payoff for each player to every possible strategy of the other players, and then looking for the strategy profile that consists of mutual best responses. To understand it better, let's just start with a simple example, the prisoner's dilemma, where two suspects A and B are arrested and interrogated separately. They can either confess or stay silent. Here are the payoffs. Let's mark the dominant strategies for both players with the asterisk symbols. If you haven't watched the previous episode, I highly recommend you to watch it first and then come back here. Assuming that both players are rational, from A's perspective, if B confess is the best response for A, since 5 years in jail is better than 10, and when B stays silent, getting 0 years of prison is better than 1 year. So confessing is still the best response. Since it's a symmetric game, the same goes for B. So confessing is the best response for both players. Every outcome that has all payoffs marked as the best response is the Nash equilibrium, in this case the -5 and -5 payoffs combination. For our second example, let's take a look at the battle of the sexes game, where a couple wants to go out for a date. They can either go to a football game or a ballet show. They prefer to go together rather than alone, but they have different preferences over the events. The husband prefers football to ballet, and the wife prefers ballet to football. We assume that they make the decision at the same time and without any negotiation. What is the Nash equilibrium in this game? I'll give you some time to think before. Let's see from the husband's perspective. If he thinks his wife will choose ballet, he will choose it too, since going to ballet with his wife is still better than being alone. So getting 1 is better than 0, but if he thinks she will choose football, he'll choose it for sure, and hence he'll get 2 instead of 0. Similarly, if the wife thinks her husband will choose football, she'll better choose the football as well, since then she'll get 1 instead of 0. But if he chooses ballet, she will choose the same, with 2 better than 0. In this game, there are 2 pure Nash equilibria, the one when they both choose football and then when they choose ballet. Let's have one last example, matching pennies, where 2 players each choose to show either heads or tails of a coin at the same time. If the coins match, A wins and B loses. If the coins do not match, B wins and A loses. How about this game? What is the Nash equilibrium? I'll continue with the answer in 10. In this game, there is no pure Nash equilibrium, because there is no combination of strategies that is a mutual best response. For A, the best response to B choosing heads is to choose tails, and vice versa. For B, the best response to A choosing heads is to choose tails, and vice versa. To solve this problem, we need to use a mixed strategy, which we'll cover in the future episode. So understanding Nash equilibrium is very important in determining which strategy we should use. But what strategies are there in game theory? In the next episode we'll explore the famous strategies such as tit for tat and grin trigger. So thank you so much for watching till the end. I hope it'll help you solve any problem in no time. Please like, share, and subscribe for more videos like this. See you next time.